Hello. So, 6.1 is the first lesson of chapter 6, which talks about matrices and determinants. So, we're going to start with 6.1, matrix solutions to linear systems. So, first, we're going to define matrices. They are used to display information and to solve systems of linear equations. A matrix, so the plural version of it is matrices, is a rectangular array. So the information is arranged in rows and columns and placed in brackets. The values inside the brackets are called elements of the matrix. So here's an example of a matrix. It's inside the brackets. It has the rows and columns and elements in it. Now, next, we're going to look at an augmented matrices. So the first step in solving a system of linear equation or linear equations using matrices is to write the augmented matrix. An augmented matrix has a vertical bar separating the columns of the matrix into two groups. So the coefficients of each variable are placed to the left of the vertical line, and the constants are placed to the right. If any variable is missing, its coefficient is 0. So let's look at two examples of augmented matrices. So our first one, system of linear equations, we've got x, y, and z. So we're gonna, when we're writing the augmented matrix, our first column is going to be for x, a coefficients of x. The second column is going to be for the coefficients of y, and the third column is going to be for the coefficients of z. Then we'll have that vertical line, and then we'll have the constants. And all this is inside brackets. Now, actually, that's kind of, so the x, y, z, and c are not part of the matrix. Um, it's just showing you what we're doing. So the coefficient of x is 3. That goes in here first. Coefficient of y is 1. Coefficient of z is 2. And the constant is 31. So our first equation is on the first row. Second row, second equation is going to be 1, 1, 2, and 19. And the third row is going to be 1, 3, 2, and 25. Okay, let's look at this next um, system of linear equations. The first equation is an easy one. So we're going to write the coefficient of x is 1, the coefficient of y is 2, and the coefficient of z is -5. Then we have the vertical line, and we have the constant as -19. Now, our second equation, you can see that we're missing the x. That means that the coefficient of x is 0. So we're going to write a 0 instead of just leaving it blank. Coefficient of y is 1, coefficient of z is 3, and then the constant is 9. And now for the third equation, we don't have x or y, so those coefficients are going to be 0, and then z is 1, and constant is 4. Okay, those are examples of augmented matrices. Now, here's another example of writing an augmented matrix for the system of linear equations. Again, we need to make sure that we are writing each x, y, z, and the constant on here. So our first equation, the first coefficient is 1 for the x. The coefficient for y is -2. We don't have z, so that's going to be a 0. And then our constant is going to be 2. Second equation, we've got 2, 3, 1, and 11. For the third, we're again missing x, so the coefficient is going to be a 0. Y is 1, z is -4, and the constant is -7. Okay, next we're going to look at matrix row operations. So a matrix with ones shown on the main diagonal and zeros below ones is said to be in the row echelon form. We use row operations on the augmented matrix to produce a matrix in this form. So here's an example of that. We have ones in the diagonal and zeros underneath it. So the following row operations produce matrices that represent systems with the same solution set. So our first step is that the two rows of a matrix may be interchanged. This is the same as interchanging two equations in a linear system. The elements in any row may be multiplied by a non-zero number. This is the same as multiplying both sides of an equation by a non-zero number, which we've been doing. And 3, the elements in any row may be multiplied by a non-zero number, and these products may be added to the corresponding elements in any other row. This is the same as multiplying both sides of an equation by a non-zero number and then adding equations to eliminate a variable. So two matrices are row equivalent if one can be obtained from the other by sequence of row operations. Okay, let's look at symbols for row operations. So each matrix row operation in the preceding list can be expressed symbolically as follows. We're interchanging the elements in the ith and jth rows. That means that we're going to write a capital R with a subscript of I, an arrow with pointing each way, and then a capital R with a subscript of J. So this means that we interchange the elements in the ith and jth rows. Then we can multiply each element in the ith row by k, so that would be k times Ri. Add k times the elements in row I to the corresponding elements in row j. So k times the elements in row I, k times elements in row I, we're adding to the corresponding elements in row j plus row j. And it goes in row j. So whatever is the last one here, that is the row that we are kind of changing the numbers on. That's where we are rewriting. All right, so now we're going to start performing matrix row operations. So we're using the matrix or this matrix and performing indicated row operation. So we are interchanging row 1 and row 2. Let me rewrite this here. Okay, there's the vertical line and then the brackets. So we are interchanging row 1 and row 2, so it means that these two rows flip. So now our row 1 is going to be 1, 6, -3, and 7. Our row 2 is going to be 4, 12, -20, and 8. And our row 3 is -3, -2, 1, and -9. Okay, we're using the exact same matrix, and now we are performing row operation 1/4 to row 1. So that means that when we've got our matrix here, vertical line and brackets here, and we are doing 1/4 row 1. We are multiplying each of these by 1/4. Each element in row 1. So our new row 1 is going to be 1, 3, -5, and 2. Row 2 and row 3 did not change. Okay, next one, we are going to be multiplying row 2 and adding row 3, or adding it to row 3. So 4, 12, -28, 1, 6, -3, 7, -3, -2, 1, and -9. So multiplying row 2 by 3 and adding it to row 3. So our first row, oops, I'm missing the vertical line. The first row and the second row has not changed. We keep those the same. It's the third row that we are changing. So we are multiplying the second row by 3 and adding it to the third row. So 3 times 1 plus -3. So the corresponding elements. Here we have a 6, so we're going to do 3 times 6 plus -2. -3, so 3 times -3 plus 1, and 3 times 7 minus 9. So 3 times 1 minus 3 is going to be a 0. 3 times 6 minus 2 is going to be 16. 3 times -3 plus 1 is going to be -8. And 3 times 7 minus 9 is going to be 12. Okay. Next, we're going to look at why are we using these, or how are we using them. So we're solving linear systems using Gaussian elimination. So our first step is to write the augmented matrix for the system and then use matrix row operations to simplify the matrix to a row equivalent matrix in row echelon form with ones down and the main diagonal from upper left to lower right and zeros below the ones in the first and second columns. So this is our goal. Then we're going to write the system of linear equations corresponding in the matrix in step 2 and use back substitution to find the system's solution. Okay, so we are going to be using this. First, the very first step is to write the augmented matrix. So 2, 1, 2, 18. 1, -1, 2, 9, 1, 2, -1, and 6. Now we're going to use matrix row operations to simplify the matrix. Now, our goal here is, or the very first thing that we need to do is we want a 1 on the first row, first column element. And if we look at what we've got here, we already have a 1 in the second row. Yes, we have 1 on the third row as well. So we could actually interchange row 1 with either one. I'm just going to go ahead and interchange it with row 2. So now our row 1 is going to be -1, 2, and 9. So the one that used to be row 2, and our row 2 is going to be what was originally our row 1. So we're just flipping those over, and that's 18. And our row 3 did not change. Okay, next, what we're going to do is we need, so we have a 1 already in the first column, first row. We want a 0 in the next row in the first column. So we need some sort of an operation that will give us a row operation that will give us that 0. Now, when we want zeros, we are adding, and we're adding to row 2 something. Now, I'm going to go ahead and multiply row 1 by the opposite of what we have here in the first column in the second row. So that would be -2. And I'm doing that because -2 times 1 plus 2 will be 0. Our row 1 does not change, and our row 3 does not change. So those stay the same. It's just row 2 that we are now adding. Our next one is -1 times -2, which is 2, plus 1, that's going to be 3. -2 times 2 is -4, plus 2 is -2. -2 times 9, which is -18, plus 18 is going to be a 0. Okay, now our next step, I need to make sure that I've got enough room. Our next step, we have 1, 0. We need a 0 down here in the third row, first column. We want to make sure that we're doing it in this order, or it's going to mess up when we start going to the second column. So our first row, we're not changing anything. And we're actually not changing anything in the second row either because we don't need to. That we have the 0 right now, and that's what we want. Now, for us to get a 0 on the third row, we will be adding to the third row. This shows that it will be adding to the third row. We will be using row 1 because that's the only one that has a 1 or an element here. So we'll be doing the -1 times row 1. Because if we do negative, remember this is the one that we're using. So -1 times 1 is -1, plus 1 is going to be 0. -1 times -1 is a 1, plus 2 is going to be 3. -1 times 2 is -2. -2 minus 1 is -3. -1 times 9 is -9, plus 6 is -3. Okay, now, and sometimes when we're doing this, it's going to be a trial and error. It doesn't, you might start one way and then have to, restart, or you might take a lot more steps to get these done. It's not exactly okay, these are the exact steps that we are doing. Next, what we're going to do to make this a little bit shorter, and this is the step that you might not think about doing, especially when you're starting these, is we're interchanging row 2 and row 3. We can't, so row 1 has to stay as it is because we have that 1, and we need the 0 and 0 here as well. So our row 1 did not change. We are interchanging row 2 and row 3. So our new row 2 is going to be 3, -3, -3. Our new row 3 is going to be 0, 3, -2, and 0. So all we did was flip these two. And there's a method to the madness. Okay, next. So we have 1, 0, 0 here. Our next goal is to get a 1 right here. So our first row is not going to change. That's going to stay -1, 2, and 9. We don't want to touch it because we have the one that is our goal. So whatever we're doing, we are doing to row 2. Now, when we want a 1, what we want to do is we want to multiply by the reciprocal of the element that we want to become 1. So the reciprocal of 3 is 1/3. Now, when we multiply 3 times 1/3, we get 1. 3 times -3 is -1. And again, I'm sorry, not 3. 1/3 times -3 is -1. And 1/3 times -3 is -1. Okay, our row 3 did not change. That was kept the same. Now, next thing we have, so we have a 1, 0, 0. We have a 1. Our goal is to get a 0 in the second column of the third row. Our first row, we're not touching. That stays the same. We are not touching the second row either because we don't want anything changed in it. Now, when we want a 0 on the third row, we are adding something to the third row. And what we need to do is we need to look at, we have a 1 in the second row, and we have a 3 in the third row. So we want to multiply row 2 by -3 because -3 times 1 plus 3 is going to end up being a 0. Yes, could we have done negative or 3 times row 1 plus 3? The only, well, no, we could have made this 0, but if we had added something to here, we would have changed that to another number, so we can't do that. You have to remember that we need to keep that 0 there. That is why we're using row 2, because it has 0. If we do -3 times 0 plus 0, it's going to be a 0. Okay, our third column in the third row, and -3 times -1 is going to be a +3 minus 2 is a 1. Well, actually, that is what we wanted here. So that worked out well. Okay, we need our the constant. -1 times -3 is a 3, plus 0 is going to be a 3. Okay, so we've got x, y, z, and our constant here. We got what we wanted. We have the ones in the diagonal and then zeros below it. So we are going to write this system of linear equations here. So our first equation here is going to be x minus y plus 2z equals 9. Our second equation, we don't have an x because it's a 0. It's y minus z equals -1. Our third, we have zeros where we've got x and y, so those coefficients are 0. So all we have is a z equals 3. Now, why did we do all this work? Because now we know that z is 3. What we're going to do is we're going to take the second equation, y minus z equals -1, and we are plugging this 3 in here. So y minus 3 equals -1. Well, we get y equals 2, right? Now, we're going to take our first equation. We don't know what x is. Our y is a 2. So -2 plus 2 times our z, which is 3, equals 9. So x minus 2 plus 6 equals 9. X plus 4 equals 9. X equals 5. There we go. We were able to solve the order triple for this system of linear equations. Now, of course, the one step that is not mentioned here is for you to go back and check. So what you need to do is you need to plug all the order triple back into the original and make sure that everything comes out as true, all three equations with the order triple. Okay, so this is one way of solving the linear systems, which sometimes might be easier when we have three variables than what we've been doing with the substitution and addition methods that we did in the previous lessons. Now, we're going to look at another method, which is the Gauss-Jordan elimination. This is, we start like we did the previous one, but we go in even farther. So what this wants us to do is that we have, again, the ones on the diagonals and zeros underneath, but also we have zeros on the top. And then we'll have our constants over here in the augmented column. So for this one, once we do it, it'll be easy to, just say x equals a, y equals b, and z equals c. So what we're going to do is, and this starts the exact same way. So we want a 1 in the upper left-hand corner, and then we want zeros below it. Then we want 1 in the second row, second column, and then we want the remaining entries in the second column to be 0. So we always start with the 1 and then we figure out how to get the zeros. So what we're going to do, this is the exact same matrix that we just did in the previous example. So what I'm going to do is I'm going to continue from previous example because there's no point for us going through all the steps that we did. So I'm going to take this one right here, and we're going to continue from there. So we have 1, 0, 0, 1, 0, 1, and then the rest are -1, 2, -1. The augmented column is 9, -1, and 3. So right now, our goal is to get this to a 0. So what we want to do, again, if we need a 0, we are adding. And we are adding to row 1. Now, look at this. This has a 1 and this has a 0. Well, if we add 0, that's not going to help. But if we add 1 plus -1, we get a 0. And that was our goal. So we are adding row 2 to row 1. So our first is going to be 0 plus 1 is 1. 1 minus 1 is a 0. The third column is going to be -1 plus 2, which is a 1. And the augmented column is going to be -1 plus 9, which is 8. Now, again, we've got zeros here, 1, 0, 1. And then we have, oops, -1, -1, 3. So we're getting closer. Our next step, what we want to do is we want to make this a 0. So 1, 0, 0, 1, 0, 0, 1. So we are again wanting that number to be a 0. So what we need to do is we are adding to the second row. Now, looking at the -1 and 1, 1 plus -1 is going to be a 0. Well, we are adding the third row. Because, so the first row does not change. The third row does not change. So row 3 plus row 2. 0 plus 0 is 0, which we have here. 0 plus 1 is a 1. 1 minus 1 is a 0. 3 minus 1 is a 2. Okay, we've got one more here. This right here that we want to get rid of. So it'll be row 1. And again, since we want it to become a 0, we are adding. Well, here we have a 1. So we can take the negative row 3. So negative 1 times row 3 and add it to the 1, and we'll get a 0. Our first row, well, if we add a negative 0 to 1, we still have the 1. If we add negative 0 to 0, we still have a 0 there. Negative 1 plus 1 is going to be a 0. Negative 3 plus 8 is going to be, is going to be 5. Now, all other rows are going to stay as they are. 0, 1, 0, we're not touching them. And now we have the what we wanted. We've got ones in the diagonal and zeros under and on top of it. We can rewrite this. This is again x, y, z, and c. Now we have x equals 5, y equals 2, and z equals 3, right? So we got the exact same order triple that we did in the previous example, just a little bit differently. So these are two different methods to use um, when we are solving linear or systems of linear equations with 3 variables. Okay, that's it for this lesson. Let me know if you have any questions. Bye.